In my last video, I talked about invisibility holodeck theory um, with what I call a lenticular box, which is not truly lenticular, but it's a predecessor photographic technique that led to true lenticular technology. And then I touched on the high-tech part of the inverse relationship between invisibility and holodecks, and also that the holodeck is a byproduct of making something invisible. Well, in this video, I call it high-tech invisibility and holodecks, and I use a sphere as a general form, which can be applied. The sphere can be deformed topologically into any other thing with a closed surface, any other object, three-dimensional object with a closed surface, one closed surface. Here's three things you should know, or three basic things about the sphere. And this is not my artwork, it's something else, somebody else's. I wish it was mine. I wish I had the capability to do that. A sphere renders the highest 3D resolution of any solid object, but the 2D resolution can increase the 3D resolution. And what I mean by that, by having more, if you thought of these as three-dimensional pixels, these are just hexagonal plates, I guess, or whatever, around this whole thing. And I used this a long time ago as a proof to myself that you can evenly distribute pixels symmetrically around a symmetrical sphere, and a highly symmetrical sphere. And you can read that in books, but visualization helps a lot to prove it to yourself. But anyway, 2D resolution can increase 3D resolution. What I mean by that is the more pixels you have laid out on this flat surface, it increases the more angles of view that is captured. But there's not necessarily any way you can increase the 3D sphere's resolution except for increasing the 2D pixels on the surface, the 2D space of the pixels and the 3D pixels. And the next thing, the highest resolution of any solid object will always be lower than its true resolution within the interface, aperture width. What I mean by that is that this resolution on the surface is always going to be lower than the true resolution that you can obtain from the apertures, as long as they're larger than the wavelength of light being sent through in a light field assembly of this type, modified light field assembly. And when you get to the length of a wavelength, when you get to the width of a wavelength for the aperture, light can't go through this, and this whole thing wouldn't work. So the smallest Planckian type, I'm used to thinking about that, Planckian type element or whatever unit is the smallest, is the aperture width, so long as it's higher than the wavelength being sent through, or the width is larger than the wavelength being sent through. After that, no light can go through. So, but the true three-dimensional resolution is found in the interface. Anything outside, the larger it gets, the lower the resolution, 3D resolution. And the last part of this doesn't really need a picture, but the 3D resolution of any irregularly shaped object can only be statistically measured. And what I mean by that, I don't mean like a cube or a pyramid or a prism or something like that. I mean something that's like an invisible suit that conforms to the human body or an animal body, I guess, I don't know. It's so irregular it would be really difficult if there is a solution to the resolution, 3D resolution of that object. It would be really difficult. Maybe someday in the future, somebody will find a way to measure it. For now, I've only discovered that, and I haven't really actually discovered how to statistically measure it, but I know that I'm pretty sure it can only be statistically measured because the different rotations of an object, an irregularly shaped object, is going to produce different 3D resolutions. And maybe you can calculate them all, but I'm talking about really small pixels, and I'm talking about really big surfaces. So it would be nearly impossible, but it could happen. But in my educated opinion, the 3D resolution of any irregular shaped object can only be statistically measured. And so that's what I have to say about the Holodecks in its most basic form of a generalized sphere. These are the three things to take away from this. And I'll include these into the video. Well, thank you.